All right. The presentation works? Does it work? Yeah? Perfect. Okay.
Yeah.
Great, great.
Hopefully.
All right, yeah, I can see it too. So please let me welcome our next speaker, Dominik Hana from IBM, who will speak about flowing through failures, workflows in Kubernetes. Please, a big applause to welcome Dominik on the stage.
All right, so hello everyone. I'm Dominik Hana. So I will be talking about workflows in Java and how you can ensure that if you're running these Java workflows on Kubernetes, that even though you encounter some pod failures, you can still finish the execution of that workflow and you don't lose it. You don't lose the progress you already did. So first, let's just set the ecosystem of these talks, where we'll be moving. So we'll be talking about CNCF Serverless Workflow Specification project, and also in Java ecosystem, which is namely in Quarkus, and the new member of the community, Quarkus Flow. In case you don't know, so Serverless Workflow presents a vendor-neutral, open source, and entirely community-driven ecosystem, which is tailored to define and execute workflows using DSL in the serverless realm. And Quarkus, just maybe to get the picture, who knows Quarkus? Not many? Yeah, so Quarkus is a Java application framework tailored for Kubernetes. So you can build Kubernetes native Java applications, and it comes with lots of benefits and a huge ecosystem of libraries that you can use to develop your Java applications that are Kubernetes native. Yeah, if you are interested more, just check out the links and visit the websites to learn more about this project. So, brief agenda. I'll start, since this is a beginner talk, so I'll start with what is workflow and why would you need a workflow. Then I'll introduce the Quarkus Flow framework. We'll talk about what the durability problem is when you're running workflows in Kubernetes. I'll show you the solution, and at the end, if the time permits, I'll show you how it works in practice. So, what is workflow? Workflows can be pretty much everywhere. You can define everything as a workflow from your morning routine or from what your application needs to do. But in general, it's some sequence of ordered tasks, steps, transitions that you do to achieve a goal. Or you can say it's a repeatable roadmap that consists of trigger, task, and some outcome. Or even like definition of the business logic that you want to execute and manage, right? Or we have a definition from Workflow Management Coalition, which formally defines it as the automation of a business process in whole or part, during which the documents, information, or tasks are passed from one participant to another for action according to a set of procedural rules, okay? So now that we at least know or we have the general picture what the workflow is, why would we need them? Okay, so that's a lot of there is a lot of like points why would you want the workflow or use them, but I just took for the introduction purposes, I'm mentioning these three. So first is efficiency. So if you define the workflows in an application, you are basically eliminating guesswork. So you put it on paper, you set the rules, you clearly outline what needs to be done, and then it's clear who does what and when. And since you have the clear definition of what needs to be done, you can easily redefine or improve in case you identify bottlenecks, etc. So the whole define, implement, execute, monitor, improve loop is available to you. Okay. Next up would be error reduction. Since workflows provide standardized rules and conditions, then they prevent steps from being skipped. So it's like you have a recipe, and if you follow a recipe, you generally reduce errors. And lastly, once you define your workflow, you can easily share it across your application or company or business, which again eliminates error because someone who never did something just follows some sort of recipe, and the outcome should be the same. And lastly, we have automation. So if you define your workflows, you can generally automate them and run them on demand when needed. And when you run them on demand, you can implement things like monitoring, observability, and you can check what they do, how they do it, monitor them, identify bottlenecks, and do things in an automated manner. So based on some input, I execute some workflow and get some result. So this is heavily used in software platforms, like for routing documents, automating backend approval chains, or augmenting data, for example, or notifying people, the right people, based on some condition, etc. And in general, in orchestration and choreography of services, if you automate it using workflows, it's much more predictable. So here is a simple example of workflow. For example, let's say this is your business logic. You need to, you're defining how to request cloud access. So based on some new request, you first log the request, then you wait for manager approval, and then you provision access, okay? So each of these tasks can do different things. It depends on how it is implemented. But all of this is repeatable and should happen exactly the same for each user that is requesting access to cloud. So you can use this then and implement this workflow in your application in case you identify it. Yeah. So to implement it, you can use some engine. We will get to it, but if you never did it and you want to make an application that does this, you would do some if-then-else statements in your resource and produce the result. However, here comes a challenge, which is time. So one of these tasks, or each of these tasks, can take time. So, for example, the wait for manager approval can take either days or hours or even weeks, based on that. If the manager is on a holiday, right, you need to wait. So you obviously don't want to use thread sleep, because you would block the thread on the server, and that is not efficient, right? And you want to use the thread for something else, and you want to manage your resources efficiently. So how would you implement the workflows in your apps, right? You don't want to do it manually. So if you don't know any engine, or you don't know that engines exist, you would start something with some workarounds. So you could deploy some callback webhooks, or some event-driven choreography where you had some brokers that will signal you that the manager finally approved, or some database poller that, okay, when the database is updated, you can resume the workflow somehow, okay? But all of these are kind of like workarounds, because you would need to manually manage the state of the workflow. So, which is you are tangling the infrastructure routing, like cron jobs or database polling, directly with your business logic, which is not ideal, right? This topic is more broadly elaborated on in this blog. Feel free to scan it and check it out. It's from my colleague Riccardo Zanini. And so naturally, what would be the solution? The solution would be to separate the workflow from the application code, leveraging some sort of engine. So we call it workflow engine. So the workflow engine acts as a dedicated code template for your workflows. So it takes responsibility for routing data, tracking state, enforcing rules, and allowing your microservices application to remain stateless and only focus on the execution. So the workflow engine's value is not just you are drawing diagrams and making it nice, but you are recognizing that the state management, event correlation, or process routing are infrastructure concerns, not business logic. Yeah, so the engine can also handle things like thread safety, managing the threads, so etc. So here comes Quarkus Flow, which is exactly a library that provides you with the workflow engine. It's a lightweight, native-friendly workflow runtime library built on top of Quarkus. So all of the Quarkus benefits, you can read on them on the web page, but it's like build-time optimization, developer's joy, the huge ecosystem of very good libraries that you can use in your applications. All of that is bundled when you use Quarkus Flow. This Quarkus Flow brings the Serverless Workflow Specification from CNCF directly into Java. So we implement the Serverless Workflow Specification using the Java SDK. And yeah, so it allows you to embed the lightweight workflow engine into any microservice. So if you want to execute workflows in your application, you can do that in your Quarkus applications, you can do that by including this extension. More about Quarkus Flow. So it leverages Quarkus's built-time optimization and also compares natively to GraalVM, which is resulting in a nice performance benefit. So the engine boots in milliseconds, which is very good in scale-to-zero architectures. It allows you to define orchestrations using type-safe flow in Java DSL. So instead of writing YAMLs, you are writing Java, which is type-safe, and all of the other benefits that come with Java. Of course, YAMLs is also supported. If you are interested and like YAMLs, you can still use YAMLs. No one prevents you from doing that. But having the type safety of Java and other benefits is, I think, pretty awesome to have. And lastly, AI is like first-class citizen of this extension. So you can easily implement agentic workflows in your applications. Okay. Basically, we are integrating LangChain4j. So if you want to orchestrate multiple agents and do something with their output, augment it, etc., you can use Quarkus Flow for that. Is there anyone who knows what LangChain4j is? One, okay. So LangChain4j is a Java library that aims to simplify integrating LLMs into Java applications. So it gives you like API to send requests to LLMs, get some response, control the system prompts, classic prompts, control memory, and all the parameters that you can configure when you are running LLMs somewhere. But this is not the topic of the talk, so if you're interested, there is a link, but just LangChain4j on GitHub. It should give you the result. And lastly, I mentioned agentic workflows. So what is agentic workflow? What is traditional workflow? So in traditional workflow, you follow some explicit predefined software paths, and you usually coordinate services and handle business data. Okay, so it's like choreography of microservices over traditional protocols like HTTP OpenAPI, or reaction to external brokers like via cloud events. And often they are predictable. So if you get one input and all of the inputs from the external services that you orchestrate are same, you get the same output. Whereas the agentic workflows are orchestrating AI agents. Okay, so you have workflows which directly embed some LLMs. So you can do that in sequential or parallel way, but in agentic workflows, you are dealing with non-deterministic output of these LLMs. So you need to like handle mapping of text responses to some Java objects, for example. You need to implement guardrails, have some mechanism where you need to wait for human approval, for example, etc. So like example could be where you have some draft, revise, and critique loop, which one agent would draft some draft, then will be another agent which criticizes the draft, and the third agent which will revise it. And let's say after third loops, you send it for a human to review, so you actually get some output and some human approves that, yes, this makes sense. So here is an example of traditional Java workflow. Yeah, how it's visible. This is how you do it in Quarkus Flow. So you have some builder, create a workflow named hello, and you have tasks. So it first sets the internal context of the workflow to some message with hello world, and then it will send a post request to some endpoint with this message. Simple, very, very simple traditional workflow. Whereas in the agentic one, you have, again, 3 tasks, but first one is basically listening to an event. Second one is asking agent to do something with the input. And you can see the new hire request and new hire review class, those are basically the input. So the engine knows that, okay, I should receive this typed, this class, and if it can't, let's say, transfer the input to this class, it will fail you. It will tell you that it's received something incorrect. Yeah, but very simple, listen to an event, ask agent to process it, and in last step, we are emitting an event with the agent's response. Here are links to our documentation repository. Feel free to check them out. Contributors are welcome. It's quite new. We are approaching 1.0 release soon. So any help, or if you're interested, please check it out. We have a workshop that will take you from implementing basic Hello World workflow to augmenting it with events to augmenting it towards agentic workflow. So it's like a whole step from the basics to agentic workflows. And I mentioned here that they are different, but nothing bears it from doing it together. So you can have service and even orchestration with agents. It doesn't really matter, but we can differentiate. Okay, so now to the durability. So since this is all Java, we have some in-memory state, and I have 3 problems that I highlighted, or when we were working with this, on this topic that I think are quite interesting. So first one is stateless Java expectation. So Java microservices tend to be stateless. You just want to receive some input, do something with data, send it somewhere, and then you don't really care about the state of it, right? But if you start baking workflows into microservices, you come with that workflows are inherently stateful. So you want to see the workflows are running, post, waiting for something, and they have internal context, which is important to you because it stores the either agent responses or responses from the external services. You want to keep and have it. So, and they tend to be long running. So as I mentioned, the human interaction can take time. The agent response time can be quick, but it can also be long. And also, if you orchestrate multiple services, it can also take a lot of time. So that would be the first one we need to deal with. And so this would be like an example, right? So let's say you have new hire workflow. So you get a new hire request. On the bottom, you see some, let's say, workflow context, the data. You get agent to analyze the CV. It will tell you if the candidate matches the position requirements or not. Then you ask human to review, which can take, again, days. And then you either send him to interview or send him a rejection email, yeah? So if, for example, between the AI analysis and human review, our pod where the application is running dies, we are dealing with the second problem I'm highlighting, is the Kubernetes pod volatility. So pods in which the applications are usually running are ephemeral, so they are affected by rolling updates, node drains, or any unexpected crash, or someone just deletes the pod for you because he thinks it's not important, right? So in that case, when that happens, you are losing your in-memory state. So it's Java application, so all of the state is stored in memory. So progress lost on all the run-learning tasks. So for example, if you waited for human approval, you lost the state. You don't know. You can't resume the workflow from the same point, which becomes costly, right? So if you imagine you have a sequence of agents, and after 5 agents process your input somehow, during processing of the 6th one, it fails. So all of those tokens you wasted in the first 5 agents, you can't easily recover them. Yeah, so for the quick microservice, it doesn't really matter. You restart it, you get the same response, it's fine. However, if you do things like this, you already wasted some money on the AI analysis, so you need to somehow solve this. So the solution would be having a state persistence, okay? In Quarkus Flow, we have a feature which is called state persistence, and it does exactly that. So it stores the state in some checkpoints, and if the pod fails, we are able to restart the state from the scratch. And instead of repeating the process from the start, from the new hire one, we remember that it was waiting for the human review. So it will just resume from that with all the data that was already present in the workflows context. And while working on this, we try to solve it like this. So we would persist, or the workflow data that is stored in the state persistent would be tied to a pod. So that should solve it, right? Of course not, because if you read the documentation, when pod is replaced, this ID is gone forever. So we ended up with a database of workflow context, workflow states which didn't belong to anything, so we couldn't restart it. So the solution for that is to leverage the Kubernetes lease resource, which is a stable Kubernetes resource. And yeah, so if we pair it to that, it works. We are able to resume the workflow. So Quarkus Flow state persistent works like we are writing the workflow state to a durable data store every time task or completes or pauses. This feature is configurable on demand, and there's lots of configuration you can do. And we support multiple persistence types. So there are some key value stores like Redis infinite span, but also traditional JPA is supported. Note that this affects performance. So if you have like traditional workflows where you care about performance, you want to execute them very quickly, this will affect it, yeah. But yeah, that's like, you need to count with that, right? So if you're interested how much each of these persistence stores affects the performance, we have a performance benchmark in our documentation. So feel free to check it out, but the Redis and infinite span, the key value stores are more suitable for this than the JPA because in JPA you have transactional overhead, which kind of slows it a bit down. But all of this is showcased in this performance benchmark documentation entry from my colleague. So now we have the demo or showcase. So let's see if this works. I'll close this now. Just mirror. Good. Yeah. So how does the demo work? So it's just a workflow. It's just a simple workflow that waits for 30 seconds. We have a like function that initiates a timestamp, and then we delay the operation for some time, which is not really informative for you, I think. It's but we are kind of modifying the workflow context with this data. So and also, if you are interested, you can do it yourself. It comes with a whole README where you set it up and go through it and kind of like educate you how it works in our framework. So I already have everything set up just because to make it more smooth. But yeah, I have it deployed. This is again all done. This is a Quarkus application deployed to Kubernetes locally. And what we want to do is we want to like trigger a couple of workflows. Then I want to delete the pod. So this console is using WebSockets to look for the workflows, and now I need to restart the port forward. This will probably take some time, but not much. So you can see it booted up pretty quickly again. And now, if everything works correctly, we should see a couple of workflows appearing here soon. So fingers crossed. I could have modified the delay to be not 30, but maybe less seconds, but yeah, now we can see I didn't touch anything. The pod kind of restarted and figured out, okay, I still have a couple of workflows in the state persistence, so it resumed them from the state, and you can see that after that, it's handed to the console. So this is how it basically works. We kind of have like leases that are paired. So when a new pod spins up, the lease is picked up by that pod, and the pod figures out, aha, I have something in persistence, I need to resume it. Yeah, and that should be all.
All right, thank you. Big applause for Dominik. So are there any questions in the audience? All right, if not, there is also Slido available.
You have a question?
Yeah? Ah, sure. Didn't see you back there as I was refreshing Slido. All right.
Thank you. Nice presentation. I have two questions, if you don't mind. One is that this workflow follows some kind of conventional description language, like there is eBPMN for enterprise business management or anything else. That's the first one. And the second one, did you consider storing the state in just pure Kubernetes resources like config maps and stuff like that?
So the second one, if we consider storing them in config maps or any other Kubernetes resources, I don't think so. But I don't think that in a config map it would work that well. I can't give you a clear answer on this, I'm sorry, but it's a nice thing to consider. But we came up that leases would be, like pairing with the leases and having a persistent is the best case because the persistence also can be, like, is a separate thing. So interesting point. And the first one I didn't catch, I'm sorry.
Yeah. So there are these, at least one in my time, 15 years ago, there were these business modeling languages which have a more formal definition, like I remember ABPM, even Java has an implementation, or activity diagrams in UML when it was used back that time. So do you follow some kind of this convention, one of these languages, or how the workflow is defined, or just what are the elements?
So the workflow, we are following the CNCF Serverless Workflow Specification. So that is it was at the beginning mentioned, but it's kind of like it evolved from the traditional BPMN notation. Then a couple of years ago, the serverless workflow was introduced, which is more like, let's say, like very simple. It's a big simplification on my side, but you can imagine that BPMN is also having like human tasks directly baked into the specification, whereas in a serverless workflow one, there is no such thing as a human task, and also, like, let's say the REST, how you do REST calls in BPMN, it's more of vendor specific, whereas in the serverless workflow specification, the REST interaction is baked direct in the specification, which is making it's vendor neutral. So, whereas in BPMN, those REST are really like different vendors did the REST interaction differently. In serverless workflow specification, it is directly baked into the spec. And yet there are models, for example, UML specification, it's still being used at the universities. I'm teaching a course where we do UML. So I think it's used, but it depends where. Like, for example, class diagrams from UML are still usable and very much helpful for everything, maybe even use case diagrams. So this is still here. Maybe not not used that much, but it's still present.
All right, thank you. Since you're out of time, I would like to thank you once again, Dominik, for your talk. Big applause for Dominik.
Thank you.